so for this problem, we have to determine and categorize the point or points of discontinuity of the function x plus 1 over 4x minus 2. So discontinuities can occur when the denominator equals 0, right? So discontinuous when denominator, which in this case is 4x minus 2, is equal to 0. Okay, so let's just solve for our x value. So if we add 2 to both sides, what we get is I'll move over here, 4x equals 2. Then we have x equals 2 over 4, which is a 1/2. So we found our x value at which there is a discontinuity in f of x. Okay, and now, so we determined where the point is, and now to categorize it. So just as a general rule, whenever you have a function and its denominator, and it has like a numerator and denominator that's not just one, but when you have a function in the denominator, when that function equals 0, then we have what's called a vertical asymptote, or vertical asymptote, okay, which looks like it. For this particular one, this would be like if your x was 1/2, then we have some vertical line going up and down, some like invisible vertical line that the graph tends to go toward but not touch entirely. So it looks something like that, or something like that. I don't know exactly what this graph looks like, but anyways, that's the general idea. So this is actually going to be whenever you have some kind of asymptotes, well, especially vertical ones in particular, that means that we have an infinite discontinuity. Okay, so here is our point right there. That's the point of discontinuity, and this is the kind. It would be infinite. All right, and just a little bit more. This is just a side note now. But where does the infinite discontinuity come from? That basically means, like, let's say we were to plug in this 1/2 in for x, so then you get 1/2 plus 1 on the top, and 4 times 1/2 minus 2 on the bottom, which of course the bottom is going to equal 0, so we have a 3 over 2, or 1.5 on the top. So the basic idea behind why it's infinite, why this is an infinite discontinuity, not just like undefined or something like that, well, the easy answer is just to say undefined, because it is undefined at this point, because we have a 0 here. But anyways, so as the limit approaches, as x approaches this 1/2 value, and it's not quite there yet on the dot, what we have on the bottom is going to be something tiny, right? 0 is a really tiny number, or something even close to 0, like 0.00001. That's going to be a really tiny number, and whatever is on the top that's non-zero, this is going to look huge in comparison. Okay, so this is basically what you guys will learn later on about like infinite limits and whatnot. This is going to tend towards some kind of infinite value. So that's where the infinite discontinuity comes from. But just for now, all we have to know is that the point of discontinuity occurs when x equals 1/2, and the type is just an infinite discontinuity. Okay?